Hey, welcome back. We started with sequences and series, and now we're going to do a specific type of sequence called an arithmetic or arithmetic sequence. What makes an arithmetic sequence is that we have something called a common difference, which we more commonly label as the letter D. The common difference is going to be the difference between any two consecutive terms. So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. So D in this case is 2. In this case, 2 minus 5 is negative 3. Negative 1 minus 2 is negative 3. So D in this case is negative 3. And in this case, it's a positive 3. 4 minus 1, 7 minus 4, and so on. So this is a big deal. I'm going to use this throughout this video. That the nth term is the first term plus the number of terms minus 1 times D. I don't have time in this video to show you where this formula comes from, but it's from a mathematical point of view, quite a pretty derivation. There are two types of sequences. We have a finite sequence, meaning we have a limited number of terms. And then we have what's called an infinite sequence, which in higher mathematics can be very, very useful and helpful for us. Next up are the series. Now, a series is just adding up the terms of a sequence. And it gets a little confusing because they both start with the letter S. I understand that. But S sub 5 would be adding up the first 5 terms. S sub n would be adding up, in general, the n terms. And the formula for that, again, it's a beautiful derivation. I wish I had time to show you where all this comes from. And there's some fun stories about a mathematician by the name of Carl Friedrich Gauss on where this formula came from. But again, I'm not going to do that in a video, but if you get a chance to look it up, it's really cool. All right, let's start. So I'm going to start with A here. And I'm going to start way up here just because I want the space. And we have 19 plus 22. So I'm noticing, first off, my first term is 19. The last term, which I don't know what n is in this case, is 235. The common difference is going to be 22 minus 19. That looks like a common difference of 3. And first off, I need to find out how many terms there are, because part of my formula is I need n. So I'm going to use this formula to get that. So I know my last term is 235. My first term is 19. And D in this case is 3. So now I'm going to distribute the 3. Combine my like terms. Now I'm going to go 235 minus 16, 219, divide that by 3. So there are 73 terms in this sequence down here, part A. Now that I have that information, I can get the sum. So now I'm going to do the sum of the first 73 terms. 73 over 2. A sub 1 is 19. A sub 73, we now know, is 235. Let's see what we get. So 19 plus 235 times 73 equals divided by 2. There we go. 9,271. So adding up all of these terms, all 73 of these terms, 73 of them, we're going to get 9,271. All right, let's move on to part B. So 3 is going to be my first term. A sub 1 is 3. My last term is 109. So it looks like I have to dig out n again. D in this case is a difference of 2. So we're going to use our formula here to get n. So a sub n is 109. A sub 1 is 3 plus n minus 1 times 2. Looks like n in this case, 8 divided by 2, 54. 54 terms. So I want to find the sum of the first 54 terms. So go here. So let's see what that is. 54 divided by 2 times 3 plus 109 gives us 3,024. So once again, I'm adding up 54 terms here, all 54 of them. When I add all those terms starting with 3 with a difference of 2, adding all those up, we get 3,024. All right, let's move on to C. C, they give us n. They tell us that n is 100. A sub 1 we can figure out. If I plug in a 1 for the I there, 1 times 4 is 4. 4 minus 1 is 3. In the last term, I can plug in the 100. That's 400 minus 1. That's 399. So the sum of the 100 terms is going to be 100. Again, I'm using this formula here, over 2, times 3 plus 399. And let's see what we get there. So I'm going to do 50. 100 over 2 is 50, times, parentheses, 3 plus 399. 20,100. So adding up all 100 terms of the sequence here, we get 20,100. Part D. Now, for this one, we got to be a little careful. Here we're starting at 0, so there's actually 51 terms. 0 to 50 is 51 terms. A sub 1, our first term, is going to be, plugging in 0, we get 7. And our 50th term, so 50, it's actually our 51st term, is going to be, plug in the 51. Actually, we're plugging in 50 there. And 50 times 3, 7 is 157. I want to make it clear. When j equals 0, I get my first term is 7. When j equals 1, my second term, notice these are off by 1. My second term, meaning j equals 1, I get 10. Now, I want to point out when j equals 50, this is my 51st term. But I'm still plugging 50 in there to get the 157. So we could adjust it to make them the same. That's a sub 0, but again, we're off just by 1 because starting at 0 there. But all of this is still going to work out. All right, so our sum of our 51 terms is going to be 51 over n times our first term, 7, our last term, 157. And let's crank that out. So 7 plus 157 times 51 divided by 2. There we go. So 4,182 is what we're going to get there. By the way, you might think it's weird that we're starting at 0. In higher math, we often start at 0. In fact, it's in some cases it's preferable to start at 0. All right, let's move on. All right, so we are to example 2. For a particular arithmetic sequence, a sub 5 is 25, a sub 9 is 13. So we are going to continue to use this formula here. In this case, n is 5. In this case, n is 9. So we're going to have to dig some stuff out here. So a sub 5 is 25, which is a sub 1, which we don't know. Plus now n minus 1 in the formula. N minus 1 is going to be 1 less than that subscript, which is 5. That's going to be 4d. We also know a sub 9, which is 13, is going to be a sub 1 plus, now 1 less than that's going to be 8d. And what we can actually do is, we now have a system of equations, which you might remember from a previous lesson. And what we're going to do is we're going to subtract this equation from this equation. So we're going to subtract. Let's do this here. Minus. So here we're going to get 12. Here the a sub 1's cancel. And we're going to get negative 4d, which means d is negative 3. Which is cool, because now we can find a sub 10, which is a sub 10 is going to be the first term, which we need to get. So let's plug this one into this here. So 25 equals a sub 1 plus 4 times negative 3. 25 equals a sub 1 minus 12, which means when we add that, we get a sub 1 is 37. So now we can go back to our formula here, now that we know our first term. 37 plus, and 10 minus 1 is the 9. And then our d is negative 3. So now we can crank that out. 37 minus, and I can see that's going to be minus 27. So a sub 10 happens to be 10. All right. So moving on to example 3. All right, if the 100th term of an arithmetic sequence is 309, okay, so what they're telling us is a sub 100 is 309. And we have a common difference, 3. Find the first 2 terms. Okay, so we know that a sub 100, which is 309, is a sub 1, which we don't know, plus 99, that's n minus 1, right? 99 times 3. And here I can solve for the first term. So we have 99 times 3, 297. So we have a sub 1, I'm going to switch a little bit, plus 297 equals 309. Subtracting, so 309 minus 297. First term is 12. Which means our second term is going to be 12 plus the difference, which is 15. Not too bad. All right, this one, the order is a little weird. We're actually going to have to find D first, then A sub 1, and then we can find the other stuff. So we're given that A sub 16 is negative 233, and A sub 35 is negative 508. So we're going to end up with a systems of equations again. So we have A sub 16, which is negative 223, is going to be A sub 1 plus n minus 1, which is 15d. And we have A sub 35, which is negative 508, which is A sub 1 plus, now it's going to be 1 less than that, 34d. And here I have a system again, system of equations. And what I'm going to do, once again, is subtract. Because the A sub 1s will go away if I do that. So I'm going to subtract. We got to be a little careful here. I'm minus minus here, so just be careful. So negative 223, it becomes plus minus minus there, 508. So we have positive 285. A sub 1 minus A sub 1, 0. 15 minus 34, 15 minus 34, negative 19. And divide 285 divided by negative 19 is negative 15. So there we have our D, which is part A, part B. So there's part B. D is negative 15. So here's one of our answers, part B. Now I can find part A. Because now I know that I can use either one of the, I'll use this top one here. So probably negative 223 equals A sub 1 plus 15 times negative 15, which is 225, I believe. 15 times 15. Oop, 15 times 15. So we have negative 223 equals A sub 1 minus 225. So I'm going to add the 225 to both sides. That's going to give me A sub 1 is 2. This is part A now. Right, A sub 1, D is here. So now I can do part C and find A sub 59, which is going to be A sub 1, which is 2, plus n minus 1, which is 58, times D, which is negative 15. So let's see what we get here. 2 plus 58 times negative 15. So here we have negative 868. That's part C. Part D, they want to know when n, or A sub n, I should say, negative 1453 is going to equal A sub 1, which is here, 2 plus n minus 1. We don't know what n is. That's what we're looking for. That's what they're asking for, which term, times D, which we know is here, negative 15. So now we have a nice linear equation to solve. 1453 equals 2 minus 15n plus 15 equals negative 15n plus 17. So I'm going to go negative 1453 minus 17, because I'm subtracting that to the other side. Negative 1470 equals negative 15n. Divide by negative 15. N equals, so it's the 98th term that will give negative 1,453. All right. Lastly, we have an application. Example 5 here. An auditorium has 54 rows of seats. The first row has 30 seats. So let's start here. A sub 1 is 30. That we know for sure. Each row has 7 more seats than the previous row. That means that D is 7. Yeah. So part A says how many seats are in row 29? So that means, pardon me, A sub 29 is going to be, we don't know what that is, but we do know that the first term is 30 plus 29 minus 1, which is 28, times D, which is 7. So now I get 30 plus 28 times 7. So there are 226 seats in row 29. Part B, how many seats are in the auditorium? So we want to add up all the seats, which means I need the last term. Once again, the formula requires n, which we already know that n is going to be 54. And we need the last term. So we need to know A sub 54. So in this case, n is 54. A sub 54 is going to be the first term, 30, plus n minus 1, which is 53, times the common difference, which is 7. So 30 plus 7 times 53. 401. So our sum, 54, is going to be n, which is 54 over 2, times the first term, 30, plus the last term, which is 401. So let's do 30 plus 401 times 54 divided by 2. All right, looks like there are 11,637 seats total in the entire auditorium. Kind of cool stuff when you think about it.